এই তোরা একটু এদিকে সর না, এই তোরা একটু এদিকে আয় না, এদিকটা টেবিলটা একটু সরে না। হ্যাঁ একটু ওই এটা আসবে না, না ঠিক আছে ঠিক আছে ঠিক আছে।
Good morning and a very warm welcome to our honorable guests and respected teachers. We have almost reached the terminus of FDP on Industry 4.0 and Smart System funded by SER, organized by IT Department of JIS College of Engineering.
We are welcoming our honorable speaker, Dr. Arokia Raju, Arunachal Kasi, Professor of IIT Madras. He has more than 20 professors in renowned journal. So big round of applause for sir. So I would like to request our principal sir to felicitate sir. Today, sir will enlighten us the topic digital twin. Sir.
Thank you so much. Good morning to all of you. So I hope you can hear.
Yes, sir.
Yes, sir.
Okay, all right. So sorry for the delay. I was supposed to start at 10:30, but it got delayed to some delay of arrival and so on. Actually, this is the topic. When I looked into the topic what Sir Tata was giving me, I don't work directly with the industrial 4.0. Then I thought, what should I prepare and so on. I'm from mechanics and materials background person, so this is something new. The topic is also new to me. Then I thought that okay, sometimes in the last minute, some guests come to our home without informing us in the late evening. We may not have dinner, right? So quickly 2 minutes noodles we make it and then quickly we give it to them, right? The same thing like last minute I tried to pull out few slides what was available and what we are thinking of working in that line. Probably may be a good idea to initiate that. So that's the reason why I thought I picked up this particular topic. Though I'm not expert in that topic, this is something new for me also. Probably this will be kind of a discussion mode, between and all of us. So some of you who are already working in digital twin, if I make mistake, kindly pardon me, and you can also correct me time to time if I make any mistakes. So the first point, what I would prefer, if you have any questions or any time you can stop me before we continue the discussions on this one. Any questions or anything from your side? Not even started, then you are asking us to ask questions. That's what we need to say, right? So at least we would say that we first start in the class that one ask them the questions, then we will start it. Probably we are all faculty. So the same attitude came here also, that I just asking the questions before I start what we wanted to discuss. All right. So how many of you are aware of this digital twin? The name? Okay, good. So I see some of you you might be knowing in the aerospace industry. In India, the failures or catastrophic issues with respect to this aircraft industry is very, very less. You cannot find, except in 2005 or so, one accident had happened in Bangalore. Apart from that, we don't have any major issues with respect to the aircraft industry in India, aviation industry. Okay. But even if you look into the developed countries, there is a major concern for the safety of the aircrafts. Couple of reasons. One is the number of aircrafts they operate in the big countries is like 5 to 10 times more than India. The other one is like that one, our DGCA norms are very, very strict in such a way, stringent in such a way that one, and we cannot make any basic, at least from the life point of view, we cannot take any risk on that. People may serve the food in the common place, that's a different story. These are all not major concern for us. Have you thought about that one? Why we are so good in avionic industry? We are able to survive without any major catastrophic accidents. Any idea about that? Have you read somewhere in the newspapers about this? I'll put it in a little different way. Even in India, the so-called railway accidents are also pretty minimal, except one or two. That is a man-made. Probably it would have happened. We do not know. And otherwise, absolutely that one, the kilometers what we have the railway tracks, maintenance, everything is also very challenging. Right. So we are keep on, as a country, we are keep on improvising everything on the safety precautions. But still, means we do have lot of positivity towards in all the sense. For example, if you take any trains, you will have the springs which is kept, the bogie would have been kept in a wheels with respect to the springs. The life of the springs are 5 years. Means you can operate, you can use the springs for 5 years. But no, Indian Railway, what they used to do, every year they used to replace. Irrespective of whether the life is there or not, for safety point of view, it's a very expensive business. And making the springs, it looks easy, but it is not so. Because if you want to run for 5 years, we have to do that much, aggregated test and see that one whether it will be survive or not. Irrespective of this one, without any failure, also the people, Indian Railway used to change the springs in them. This is very, very important for our country. Some people may think that when it is over designed or we are unnecessarily wasting the money, but wasting the money is one side. The another side is like, safety we cannot compromise on this. The same thing in the aircraft industry also. So any idea why is it? So here is a standard protocol for railways. Every year, some of the crucial components they have to replace. Whether it's failed or not, it has to be replaced. There are some things which is likely to fail. Every time we have to replace. If it is working perfectly alright, also every year they are forced to replace it. So this is a protocol for our Indian Railway. Just to give an example for that. Okay. So, but it is a protocol which is maintained. Whether it's failed or not failed, people will be keep on doing this. You cannot do the same thing for aircraft industry. I'm just taking only one example like in aircraft industry. Just 90,000 feet over the sea, something happened. If it has to come down immediately, landing, it will take 30 minutes to 45 minutes, and there should be, the so-called runway should be there, and the runway should also able to take that particular the aircraft which is based on the size and the load and other stuff. All the things cannot be done. So it has to be planned properly for that particular reasons. Even some of you would have been seen in YouTube and other videos like in 2005 or 7, sometime like this. One of the American aircraft, due to emergency, they landed in New York. They were supposed to land in New York or somewhere, but Washington somewhere. But the aircraft couldn't go to that distance. So they have to land in the river. It's a very nice, wonderful documentary for this one. So it is also almost except 2-3 people, all of them are survived. They are able to retrieve everyone from there. And so like this, there are some times which is not in our hand, but still it is to happen. This one. So when you look into this one, how do you monitor? I repeat once again. How do you monitor each and every time whether the system is running or not? So we do know that one, there is a sensor. Right? Electrical engineers used to talk about, electronics engineers used to talk about the sensors and so on. Okay. Number one is sensor. Number two, the sensor senses and give the signal to some place, and there the data will be processed, and then give back an idea that what should be done for the immediate precautions what we have to do. So this is what exactly what we also do this one. Like our eyes are like a sensors, right? So something happening in front of us while driving a bike, immediately with sensor in fraction of seconds send the message to our brain immediately respond in fraction of seconds that one what action we need to take immediately. Okay. So when the action comes from controller like our brain, what will happen? Our muscles is acting as a controller. Actuation for that. Okay. Whether we need to turn that one or whether we have to slow the speed, immediately remember that all these things will happen in fraction of seconds. It may be in sometimes nanoseconds. It used to happen. Okay. And particularly if you see sometimes the doctors, neurosurgeon, when they do the surgery, something goes beyond the limit. They have to take an action within fraction of seconds for that one. Because sometimes, why I am talking about neuro, it's one of the toughest surgery. The surgeon is the highest person across the world, having the highest, what you call about the pressure when they do the surgery. Because nerves are very, very sensitive. If they cut one place unofficially or unintentionally, it will get rid of the entire problem. Completely make the system to be chaos. So they are very, very sensitive and very, very careful about their surgery. That is the reason why sometimes when you see even the neurosurgeons, they start the surgery in the early morning, 4:30 or so. They take a very nicely fresh in the morning. They start the surgery for that. So what I mean to say is one, and the controls which is acting and trying to respond to that one within fraction of seconds is mandatory for taking some precautions to that. Similarly, what used to happen to this one is the aircraft industry when they operate this one, there is a continuous monitoring will be done for this one. It will be a remote. I think some of you would have been already listen or probably would have been read about this one, IoT, Internet of Things. This one. So what used to happen that one, they place the sensors in the aircraft in different positions and it will be keep on monitoring and giving the data for this one. So it will be via Internet of Things and a person will be monitoring for a particular vehicle all the time and see that one how the performance or whether any default it has to happen. So generally what used to happen, you get the data, controller used to operate that and then give back to the actuations what action needs to be done for this one. This is what generally we would have been talked about the control loop which electrical and electronic engineers used to talk about this one. Like it's like a closed loop, keep on working on that one. But here what is happening, it's not only giving a reaction, whether with the existing default failures, how the system is going to operate now, whether it is going to immediately fail or whether it is going to stand for another 10-15 minutes. That the diagnosis and also what is the repercussions used to happen during that time, if that is also going to be given to that one, then that is what we call as a digital twin. How do you do that? Okay. The plane is running in somewhere in 19,000 feet from the sea level. Right? So how do you get this information from? Information getting is fine. But we have to simulate that one, what it is happening there to predict here, so that it will be easy to repair this particular component. That is the place where the digital twin comes into the picture. So this is very, very common in the recent days. It is not only related to, even though it represents like industrial, anywhere if you look into industrial 4.0, under this umbrella of industrial 4.0, one of them is IoT is also one of them. Digital twin is also one of these subdomain which is coming to that. Okay. Why is it important, and how we are going to implement this? It is not in only one sector. As I told you, automotive sector is one of the sector. I give an example, but it has been used in all the sectors extensively. Nowadays, people are coming up with using interdisciplinary research on that one. So the doctors also, biological people used to work, electrical people used to work, chemistry used to work, mechanical sciences used to work, of course computer science. Without that, because the data you have tons of data will be coming on that one, how to analyze and then pick the model by using the machine learning algorithm and get this information. So all these things will be interdisciplinary at this moment when you talk about this, digital twin for this. This particular digital twin, there are some already platforms are available. I mean, softwares are already developed. One of the extensive platform or digital twin is available with Siemens. Siemens have their own digital twin platform. They are the one first started off working on that. Of course, the topic is not new. The topic was there earlier also, but now it comes up with a new name with some, additional requirements. That's nothing more than that. So, this is what I thought that we will discuss about this particular, lecture. Probably, I try to pull some of the, slides which is available in the literature and also in the internet. You can see here that a digital twin is the virtual representation of a physical object, process, or the system. I mean, one more example, if you go to YouTube, just to go to this YouTube and type digital twin, you will get a lot of videos in that one. One of the video, which, it was so fascinating to see that one. What used to happen, in Europeans and even in India, particularly in West Bengal as well as in Kerala, the people like to do a lot of, play a lot of football. This is the two states are very particular about football apart from cricket across this India. So European and Americans are like crazy about this football. They will give a different name like soccer and so on. But what used to happen that one, like how we are having IPL in Europe Union, they call us this Premier League for football. It's a huge amount of money involved in that one, sponsorship and that. And one of the stadium, I'm talking about that one, the stadium, there will be 40,000, 15,000 equipments used to sit for this one. Okay. But what is the problem with that one? And the people, those who are sitting there, they always used to make noise. If India is playing, immediately people used to give the noise for this one. Okay. It is not only the people are jumping or dancing give the vibration to the stadium. The noise what people are also making, that is also is going to give a low frequency vibration to the system for this one. When we are going to design some structure, civil engineers when do the design of the structure or any other engineering people, they wouldn't bother about the noise, whether it makes any failure to the system or not, they couldn't be noted. So apparently what used to happen that one, and it was in Denmark. Please look into this one, put a Google, a digital twin on stadium, football stadium. If you do this one, there will be a wonderful video. What used to happen that, these big sponsors used to sit inside a covered room. It's a glass room which will be sitting inside that room. And what used to happen that apparently the noise and others of sound, what people are trying to make that one, when we simulate it, we try to see this one. The first failure, if the stadium is going to collapse, the first failure is going to happen nearer to the close to room where all the big shots used to sit for this one. So generally what used to happen, if anything happened to the big shot, then only the action will be taken. That's what across the world people used to do this one. Okay, the guy who is sponsoring, who will be sitting inside the room and his life is a threatenable one, then immediately action will be taken for this one. This is a common phenomenon, right? So the same thing there, if you, they would have been seeing this one, there is a place where will be vibrating a lot for this one. The first job, where do we need to put the sensor to identify the vibration? The stadium is like, it's a very, very big stadium. You cannot make 2,000, 3,000 sensors to place in many places. Only critical places, only you can place the sensors for this one. First, we need to optimize what are all the critical points and how, where to put what kind of a sensors. That is a very important objective. And the second one, the same stadium, all the architecture and all the structural things which would have been there in the computer or in the model which will be available with one person, he will be sitting remotely some other place. So what used to happen? The sensor used to give the signal to the stadium. That signal will be fed inside the numerical simulations or theoretical simulations. So it's like online monitoring. So whatever the load is going to come, you can see this one, how the system is really vibrating and how is the stresses are developed, how will be the deflections are developed, and it will show some of the places where it is beyond the yield limit. It's a threshold. That's what it is. Means if I take a class in more than 15 minutes, students won't be listening to that one. I have to exactly stop at the 15 minutes. That's a threshold for sitting in the class. Same thing, that one, there is a threshold at which only the system can operate. So you can really see at this moment in a computer, saying this one for your real system in the simulations, how online control, you can see what are the repercussions is going to happen. This is what exactly what we are talking about, the digital twin. So this is what it is also written, this one, virtual representation. You are making a virtual representation of the structure in your computer with some software, and you are trying to get the input, real-time input from that one, and then placing that input and see this one, what is happening to the structure. So that you will be able to see that one, okay, it will give the calculations of output and what is the reality. You can compare and see this one, whether we are going to immediately take action or still it will withstand before it fails further. Right. So if you consider in other, there are two things. In general, if you take a structure, I think it's very common for all of us, any bridges or anything, bridges will collapse overnight. Collapse within fraction of seconds. Particularly concrete bridges will collapse. That would have been happening in many places, right? Why is it happening suddenly? Why not, a slow phase, means it may elongate and then it may fail. That may not happen in bridges, particularly on this one. Because the concrete is kind of a material, it will take as much as the load, but suddenly it collapses for this one. That is the nature of the particular material. The typical example is our chalk piece. When you take a chalk piece and try to pull that one, what will happen that, it will resist for some time and then it will become two parts for this one. But after you become two part of your chalk, when you connect it, there won't be any change in the diameter. The diameter will be still the same for that one. At the same time, the same dimensions, if I take a rubber and if I try to pull this one, it will elongate. There is a reduction in the area of the cross section before it fails for this one. This is the two different kinds of a material. The behavior of the material is completely different one over the other for this one. So concrete is kind of a material where bridges are extensively constructed. There will be sudden failure is to happen. So if there are critical thresholds are going in my simulation, I have to immediately evacuate the people from that particular place before it fails for this one. There are some places where it will happen that, okay, you slowly take out the people, it may stay for some more time. This is the analogy we will be getting this one. So the real-time digital monitoring and the digital twin will help us to take a decisions depends upon the current situation, what it is going to happen in the structure of that. Are you okay? So what we will try to do, we will try to mimic, this is a real structure, we will try to mimic in your system and get the data, place it inside that and see back what is to happen. So if you see that video is wonderful. Like, the people will be jumping with the noises and that will be taken by the sensor. The sensor will be given via IoT to the software, the system. The system will be replicating the same dimensions, same material properties of what was really constructed by for the stadium. That will be there, like a Eden stadium, cricket stadium which we have. And then this data will go and it will keep on finding out these vibrations. And not only finding out the vibrations, whatever real system is giving, what this is projecting, it will be compared one over the other and see that one, how much variations we are getting this one. It's not only getting the variation, what is the repercussions? Like, whether within the limit. If it is above the limit, it is going to collapse for this. So that is the real-time monitor which will be very, very important in today's system, and people are working on towards this one. This is one of the typical examples for the digital twin for this. This is what exactly happens in automotive industry also. Like, real-time monitoring of automotive engines, real-time monitoring of the structures, which will happen. Somebody will be simulating the same thing and get this information one over the other. One would argue the question, sir, why is it not happening to passenger cars and the vehicles? It's a very expensive business. Like those who can afford, it can be done. Suppose if you buy BMW or Audi, now they are also having digital twin technology. Okay, you will get a car. Sir, you may not feel this one. There, sir, one of the component in your car is likely to fail very soon. Can you please take it to the garage so that we can repair it and give back to you? You will get a car because they will monitor your system. It cannot, means for 10 lakhs cars, 15 lakhs cars, probably we may not be able to afford. Suppose you buy 5 crore cars, it's like EMC, maintenance, annual maintenance we buy for UPS and other stuff. Pay some amount, they will keep on monitoring and they will tell you what is happening to our car for 2 years or 3 years or 4 years later. So this is what we are talking about. This in this particular case, digital twin. So as it is mentioned, this one is a typically like it's a virtual representation of a physical object. So I have a stadium. The same thing will be virtually represented in your software. That's a link you will be having one over the other. It is not only for this one, it is also to be a process or for the entire system. For the industry, in a day, do you know that, in a day, suppose you take any pharmaceutical industries, we are all aware of COVID, right? How many Dolo tablets would have been prepared per day during this COVID time? Any idea about that? Like tons of paracetamols are produced in a day for this one. There is a requirement. What is the capacity and how many people are working that day? In that particular day, how many people are working, how many of them got infected? They about to come for a job that particular day and they missed out this one. So that whether they are able to make like 1,000 kg is the protocol per day they wanted that one, it may not make 1,000, it may go only 900 kg for this one. So somebody will be keep on doing that one and trying to get this one. In fact, in the COVID time, it was already implemented, extensively by defense and the L&T together, mainly for this oxygen plants. So second wave, oxygen is necessary, all of us we are aware of that one, right? So India were not prepared for oxygen and extensively. Do you know how many oxygen and this mass production of oxygen units were developed in India? So across the country, 97 oxygen units were been set up by DRDO and L&T within 2 months for that. Okay. It will be in different places. We are not worried about whether it's set it up in Delhi or UP or MP, that's a different story. But overall, 97 oxygen plants were made it and are successfully incorporated. I think, see what is each and every day oxygen, how much we are producing this one, all these things, it was noticed by our PM sitting in Delhi. So in his office there is a digital display, there is an IoT sensor are placed in all the 97 things, and he wanted to watch everything that one. I wanted to see every day in 97 plants how much we are getting output, what is our requirements, and how much to improve. All the things were given in the PMO office. So for that reason, this IoT, Internet of Things based sensor have been put and all are connected with the internet to get this information for this. So, but there what is happening, there is no digital thing. It's only analyzed and manually people are trying to give the information for that. But here in this particular case, you are also trying the repercussions. I mean, what kind of failures will happen for this one. That is also not manually, simulations or whatever we are developing the theoretical model, that itself will give for this one. That is that necessitates really one step beyond what we are looking for. Are you okay? Any questions? Any questions? Okay. So, this is what it is, whatever I told, it would have been written here, probably, like as I told you that one, it is informed by sensor. Sensor is a major role to play here. So, material would have been developed by material scientists and also mechanical engineers. But designing that one would have been done by the electronics engineers for this one. Incorporated would have been done by electrical engineers. And data collections would have been done by computer science engineers for that. Analysis would have been done by statisticians or mathematicians for that. So this is the way how the interdisciplinary research is popping in today's world. That one, this has to be done for this. People are talking about now this one, means after we take this vaccine, COVID vaccine, people are trying to get a lot of, post, issues for this one. One of them is people say this one, diabetics are becoming very common after this vaccine of the COVID. How do they know that one there is a diabetes? It's all based on statistics, right? They know that one, and the number of patients of pre-COVID and post-COVID visiting the hospital, the ages for that one, and all this information would have been put in a statistical way to work on that, right? Suppose we talk to any doctors. In fact, really, doctors is also like not written, unwritten mathematical statistician. Any doctors, general physician, suppose you go for any issues, what will they do first? They will start with one basic medicine. Generally, we may not like it. We will say this one, doctor, I want it. If I have a fever tomorrow, I have to go back to job. You give me some antibiotic, 2 injections, I should be settled this one, but that's not reality. So, what used to happen that first they will start with giving some medication, whether our body is working for that or not, they will monitor. And if it is working well, then they will continue, otherwise they will change the medications for this one. How do they decide that particular one? It's all statistics. That this is a November, December, it is going to be a flu season. Because winter is going to come extensively, this is the flu season. And if you take any European countries or Western countries, the previous year, what kind of virus would have come? They would have made a vaccine for that. And those who are having chronic diseases, all the government will give free of cost vaccine for this one. But remember, that particular vaccine only depends upon the previous year. There are 7 viruses came during this winter, and they would have been made a vaccine for this one that will be given to these people in such a way that there are some cancer patients, there are some patients who are having the nephrology issues. They will be given this kind of vaccine so that it won't affect immediately because their immune will be pretty lower than others. So any viral, any bacteria will infect immediately to them. So they give that one. So this is based on the last year's statistics. Irrespective of that one, this new virus may not behave like the last year virus. We do not know about this one. But this is a statistics. Right? No, they work on this. So here also, the people used to try to work a lot in this particular case by monitoring the real-time data and then analyze and optimize for this one. Optimization is there for 200 years. There is nothing new in the optimization. Now it is coming with a new name on optimization. What is the new name for optimization? Optimization is the word there. And all of us would have been optimized everything. And even in an academic or research profile, optimization was there for a long time. But now it is coming with a new name only for this one. What is that name? What is the difference between machine learning and optimization? There is no difference. There you would have done with 200 data. In machine learning, you might be doing with 20,000 data. Tuning this one. That is the only tuning the data for 20,000 because now we have sophisticated clusters, we have sophisticated softwares. So the computational cost will be less now. So we are able to get more and more data. That's all. There's nothing different. These are all articulated name for old one. What we are trying to do now. That's the only thing which is happening in this one. Okay. So you can see here. Like this is this is one of the slides which I have taken from this one, and as we mentioned that one, and this also is trying to help to take decisions. It's not only to identify that, but it will also take decisions based on this particular problem which is in reality is happening to the structure for this one. So the prototype, test and improve the performance of the product. As I told you that one, this is not only helping for one particular case. We start with the first one is going to be like design and manufacturing for this one. In fact, this particular digital twin technique, very first it started off with typically on Scandinavian countries. What are the Scandinavian countries like Denmark, Norway and Sweden? These are all the countries. They initially started off with this digital twin technology. Because there the manpower is pretty less. The country has limited manpower, number one. Number two, that country is mainly focusing on green energy development for this one. So if you see that place as well, you will have tons of windmills. Netherlands is favorite place for winds for this one. Okay, so they thought that one, even in India, sometimes would have been seen that one, manually people used to climb this windmill and then try to clean once a year, doing the service and so on and so forth. This one. Okay. Now what is the problem with that particular one? So if you want to monitor the engine or the motor which is there in the windmill, you have to take the wire all along the way to somewhere in the ground, and the sensor should be connected, and this will, from here it will go to some other place for the data for this one. Okay. So as a country like India, now connecting all together without any power failures and so on, so managing is very, very difficult. This is the same thing which has happened in Europe also, Scandinavian countries. They are mainly running with a lot of green energy like solar energy and the wind energy for a long time. But maintenance, the wind tunnel is one of the challenging part for us. So that is the reason why what they have thought that one, whether we can start remotely to understand, to identify issues for this. Okay. This is what the first one they have made it like this. You can see here, the rear side what it is showing, this red color and the green color and the yellow color. These are all the what kind of a turbulence developed due to the wind. You will see in this one. So sometimes when you go very nearer to the fan, you will see this one, the air will be under turbulence conditions for this one. Now, very simple, in a river, suppose water is flowing on this one, at the center of this one, if there is a tree in that one, nearer to the tree, you will see the vertex will be developed on that one. And sometimes you have also seen in YouTube videos like this one, when the plane is taking off this one, when any jumbo flights are take off, immediately the small flights they don't allow immediately to fly off that one. Because the reason why the turbulence which is developed in that wind so high that one, diffuse that one, it will take some more time for this one. So if you send a very small aircraft like a 5-seater, 7-seater aircraft, it will topple. Topple means it won't fly. That is the reason why means in our passenger cars we don't have spoilers, but the sports cars, the rear side there will be a spoiler above the dicky where we keep the luggages. It is not for fancy, it is for the turbulence will be developed when the air is flowing like this. So when the air is flowing like this, there will be a curl will happen this one. This will reduce the speed for this one. So it should not happen. So it has to be destroyed for this one. So the spoilers are kept for that particular reason for high speed cars, 300 km, 250 km, sports cars, all these things. So here also what is happening is when the wind is trying to move this one, you are cutting the wind. That wind is trying to move the blades for this one. Okay. Depends upon the wind velocity, what kind of material will be subjected to the force and how that is going to react. So the real-time monitoring, this will help. It is not only to real-time monitor, this will also help us to modify the design of the wind blades and other components. So it is like real-time monitor, because once I install that one, you should not fail in 1 year. We buy and Samsung any mobile phones. Okay. What we look for that one, we look for the battery life to start with, because I don't want to change the mobile every year, probably, at least I would like to have for 2 years. So the reliability is one of the major concerns for all of us. If you take 10 years before, the life is different. 10 years if you buy washing machine, you buy it, you would like to keep for 10 years. Now it is only 2 years. You throw the washing machine, get the new brand for this. Even industry is also trying to move towards the particular direction, use and throw technology. They themselves buy back with some amount and then sell the new one out of that. These are all the strategies. From the marketing point of view, and we also like to change everything. Earlier, we made proud of that one. If I have a car for 10 years, I am having my car for 20 years, but now no more for that. So, but this is okay for in some cases, but we cannot make it like very expensive items. We cannot replace it. We cannot change every time for this one. So you need to do your control monitoring. This not only do this one, this will also try to help this one. And electrical and electronics engineers, you might be aware of the chips. So, when you have a workstation, put one question. When you have a workstations or clusters, we don't switch off the workstations or clusters anytime. Why are we not switching off the workstations or clusters? One way that every time some software, some program will be running for this. That's the one side of this. Even though if there is no program or anything running in the cluster or server, still we don't switch off that one. Why are we not doing that?
Real-time data will not come. Real-time data will not come.
Yeah, but assuming that one for maintenance itself, sometimes we are not going to switch off. Suppose I have two clusters. One cluster is running, the another cluster is not running that. But even then we are not switching off the system. We will keep on. Means you would have been seen sometimes in the computer centers, don't switch off. That would have been written this one. Why are you not switching off that? Any idea? Any servers, any clusters, they don't like to switch off. Any reason for that? I'll put little different. Why are we getting cold or fever? It depends upon the temperature. If someone to winter that one, our body needs to accommodate for that one. When it is trying to accommodate for this one, our body depends upon our immune system. It will try to accommodate, so we get sickness, and it will be there 2 days, 3 days, and get this one. Same thing. When you take a chip inside the any system, you have a chip. Chip is not made up of a single material. You will have different materials and different compositions will be there. Very simple. If you take a chip, you would have seen this one legs. Above that one, there will be a black color. So that is like a thermoplastic. Inside the one, it will do the binary operation, 0, 1, and other things. And the leaves are used to solder for this one. And inside there will be a chip that will do the job of binary operations. Would have been there is a copper plate. In the copper plate, they will keep the chip, and then they will close with the thermoplastic for this one. Means diffuse this one. This is one step. The other step is like now people will. We talk about this 4 processor, 5 processor, 6 processor, 8 processor like that. If you see in early 2000, the computers and the servers are so big. Now you can even get the servers so small. What is the technology which was developed trying to reduce this size? Is basically only one casing. Inside there will be 4 chips. Very first it starts with only single chip, then 2 chips, 3 chips, 4 chips like this. So when you put the chip inside the encapsulation, how do you place it is very important. Like the people, some of you working in electronics, they might be aware of that one. They call us a chip on chip. One chip and top of that one another chip, or chip by chip. Parallel to that one more chip they place it like this. So when you put, first you will be soldering the bottom chip, and then you cannot solder the top of the chip with the previous chip for this one, because due to temperature there may be a failure will happen. So what they do, they glue it. If I do chip by chip, then I don't need to worry, I can solder, because it will be in a single plate for this. So different materials, at least 3, 4, 5, within this 1 millimeter thickness, there will be different layers will be there if you look into this one. And what will happen to that one? Each one of them are different materials for this. These materials react in different way for temperature. How our body reacts for summer once and the winter other way around. There is a transition between summer to winter. When it is trying to accommodate, then only we get a cold and fever and so on and so forth. The same thing, the chip will also be there. What will happen that one? If it is running all the time, what will happen? It will get heated. When it is going to heat up, what will happen? It will try to expand. Right? Railway track, there are 2 tracks will be there. In between there is a gap. You would have seen this one. The tracks, if you carefully look into this one track to the another track, There is a small gap would have been given this one. Why not they weld there and polish it? It will be uniform across the length for many kilometers. This is that the gap was given for coefficient of thermal expansion. Basically, what will happen that one if you take this one in temperature, for example, places like desert in Rajasthan, like 45 degree will take in summer, and not minus degree, 10 degrees in winter for this one. So what is happening? The material will try to expand. If you do not allow to expand, what will happen? This will move up, then derail will happen. That is the reason why the gap is given to accommodate for this one. Even in all these civil constructions, if you look into this one, there will be a small gap between one building to the another building. They would have been given in between this one. This is for expansion. Even though concrete is a very good material for thermal expansion, still for safety point of view, that will be given this one. What will happen if you connect without any gap? Once you expand and fix it together, there is no other space to go this one. And then opposite side will start bulging out from this one. That is the one which is going to fail the system for that one. The same thing when you have it's a chip. Each and every component will have different coefficient of thermal expansion. So what is going to happen? I take a material, I heat it. It will try to expand. But other material, two materials if you keep it, one material will expand very fast and another material may not expand that much, depends upon the material. So what will happen? This is going to bend. It won't allow to expand, but it is going to bend. What will happen to this one? At high temperature, it will be bending position. Once I switch off that one, it will go back to the original temperature, room temperature. What will happen? This will try to go back to the original state. Tomorrow, when you switch on that one, this will bend, then go back, bend, go back. So what will happen then? Because of the reason, there will be a fatigue. Continuously, it will happen. Then it is going to happen that after a few years or so and so, the porous, there will be a gap will be started in between this one. Via that the moisture will go and dust will go, that will spoil the system. That is the reason why the people do not want structure should fail. No, the failure due to binary operation is a different story. Failure due to the structure is another story for this one. Okay, because inside the computer you don't have space constraint. 1 mm or 2 mm space constraint is not a problem. And if it is not straight, if the chip is bent already, there is not a problem for me. Whether it is bending or not, it's not a mechanical system. For me, the computer should do the binary operation, give me the results. Whether inside it is bent or straight, I don't mind for that. So that is the reason why they don't switch off the systems for them. If you after 2 years, if you remove that one and you can see the chip. You can do this exercise like before they install, you can open it out and then take a photo. Then after 5 years, you open it and take a photo. You will see there is a bend on your chip. It will be there. This is typically what is happening due to the fatigue for this one. So there are some places where this will be monitored. How for this particular system, how many years once you have to replace? Right? I wanted to improve. I don't want to replace in 5 years. I want to replace only after 10 years. Which means that I should monitor and I should also simulate for after 1 year what it is happening for. For some systems, I will be monitoring every day. For some system, I will be monitoring once a week. For some systems, I wanted to monitor once a year for this one. Like, suppose if you take atomic energy, India is mainly relying on atomic power for this. One of the very, very important system, this one. Even a small issue in this atomic power, almost in and around 200 kilometers will gone. So people used to monitor day and night for this. All the medicines, pharmaceutical companies, they have to maintain the pH content any time, not even a small amount. 99.99 accuracy they have to have in medicines. So these are all the protocols where you cannot take a rest or breathe for this one. It has to be continuously monitored. It's not only monitoring, it is also trying to improve the process, like where and all failures are having, how to change the process. For that also the digital field will be extensively used. So this is one of the examples which is given here for the design and manufacturing for this one. Though I have given an example of a windmill here, in fact it is started off with the industries. digital twin started off with the industries, then it is started percolating to the other interdisciplinary area. So people are looking into that. The next one is like smart cities, right? You can see here, you can create a virtual model of a city to help for a traffic flow, energy, and the water consumption, and so on and so forth for that one. It is there already. And I don't know, in some places what it used to happen that one, there may be a sensors, even Google does the same thing. Like, there is an inline control that one. So if you take this particular road, you will be able to reach in 5 minutes. If you take this road, is heavily traffic now in this one. This is also continuously, there is a sensor placed, and in some cities what will happen when you drive that one, there will be a board which will be displayed that one from here to that X place to Y place. It will take 10 minutes to go. There will be a display. So this will give you this one, don't get tense, to be relaxed, start music and listen to that one. It will take half an hour to reach because there is a heavy traffic for this one. Earlier days what will happen that we will use to the FM radio and see this when this road is heavy traffic and so on. But now some of the cities started off displaying that one. When you drive that one, there will be a digital board will show you that. Apart from if you don't have even our own internet to see Google Maps or whatever we are using. So developing the smart city is very, very important in such a way that this is a typical example which we used to talk sometimes in digital twin or industry relations. I don't know, there are some southern part of India, there are some hotels used to give unlimited food, 200 rupees lunch for unlimited. Okay. How do they prepare the food for unlimited? And they know that one Saturday, Monday to Thursday or Monday to Friday, probably the lunch may be 100 people may be coming. And Saturdays and the weekends, many people will be coming. So they will have statistics, footfall for last 5 years and then try to work for this one. That is okay. Yeah, another one, like they may, the same people may come, different people also may come for this one. So in a weekdays, I make 10 kg of rice. In weekend, I make 20 kg of rice for this one. But sometimes what will happen that one, means it may not go. It may not be enough also. How do they monitor? How do they promise themselves to the unlimited food for this? All of us may not be eating the same amount. But then, they don't want to make a lot and then throw it away and keep it in a freezer. This is not now. Before digital thing, all this machine learning and all, olden era also this is there. How do they find out this one? Any idea? I'll put little different. Some of us will be doing a root canal and there is a cap. Now they give a warranty for 10 years for this cap, for this one. How do you decide that 10 years? If you would have put a root canal some 10, like in 2010, they will say, sir, it will run for 2 years. After that you have to replace the cap and you have to put it once again. But now people are coming up telling this one 10 years, once you put the cap it will be there for 10 years. How do they know that? You know that any time when we buy it, we can buy only 40 to 50 times. We cannot buy more than on an average people for this one. So, a person for the lunch, if he or she is not going to talk to others and only focusing on food at a particular time, 40 to 50 times, in one bite, how much food quantity they can take, they try to calculate manually and then see this one, this is the amount which we need to prepare to weekdays and this is the amount which we need to prepare for the weekends. This is a strategy people used to do that one. And they will also add some additional compositions in such a way that one, even with 5 times or 6 times of taking the food, your stomach will be filled. They also do that one. They will add some other ingredients. It may hurt in the long term, but doesn't matter. For us, taste is important, so we eat and we come out from that. So these are all the things which manually it was done, but now it's all giving we don't need to think, something will think and final decision only we may need to look into that one. That's all. So for the entire smart cities, you can see here, and even if you see some of the digital twin and the AI based these things, all Amazon, Make My Trip, all of them, They have already implemented everything. Suppose you look into make my trip today ticket for some place, and if you open tomorrow, the rate will increase. How do they know this one? They take your IP address, and if you keep on seeing this one, even in your Uber or Ola, when you start moving from here, you would have seen, and then when you walk to down, and then you look into Uber, then you go to Ola, then some other app. Then you compare ourselves manually. By that time, you will be entering the front gate. Then you go back to Uber, the rate would have been increased by 10 rupees. Or it would have been reduced a little bit. Depends upon the number of vehicles in and around that one. Based on that one, it will change. These are all A and the ML only working on that. Okay. This is what exactly in the smart city, people are trying to look into this one. What is the capacity of the particular area? What is the soil capacity and the local area for this one? What is the water requirement for this? What is the power requirement for this one? Okay. By using this one, they try to monitor. Means all this right hand side based on the data they will see. This is where we have already seen in our Google map. It will show a red color, green color, all these things. It's like help us to understand this. Only one thing is what it is saying, one more level, that one it will suggest you don't take this particular road, you go in the other road for this one. That's what we are talking about, the digital twin. If it is only giving the information and you decide which road you want to go, that one, that's a closed loop. Digital twin is one level more than that. That itself gives you this one, there is a small road and you can go. It may be right, it may not be right. You would have been seen something like in Kerala, Google Maps showed one driver to drive and it went inside the sea or river, somewhere that one. That is also had happened sometimes that one. So, too much of digital also had a problem for this one. But failures is always that failure in anyway. You cannot make 100-proof system anywhere in the world for that one. So, one or two incidents used to happen for this one. Sometimes you have also seen this one by driving a Google map to this one. It will go to some small corners. You don't even know that one whether there is a road in that or not. That's okay, right? So there also, even though because the digital, sometimes our mind also should work on that one. Okay, whether I can take it or not. If I don't want to take, that also automatically calibrate and show the other route if you are going in the other this one. That is a speciality about this, digital twin. And in industry point of view, in a macroscopic level, what country wants, industry wants, and so on. Yeah. The another one is like in a healthcare policy. Okay. So, the healthcare, some of you might be already aware of that one, there is a pulse oximeter, right? How many of us aware of before COVID? The answer no, none of us we know about that one, right? So, what had happened that one in 2017, you might be aware of that one. There is a Jipmer, right? In Pondicherry, there is one like on par with the AIMS. There is one central government medical institutions called Jipmer. In Pondicherry, it's a very famous and very good also. The doctors are also very dedicated and so on. It's a central government like. And first one is AIMS, then Jipmer used to come this one. So we had a doctor engineer enclave for this. So as an engineers from IIT Madras, there are some 40 students and some 30 faculty. We went along with our director to meet the doctors on one fine day. I mean, I remember some holidays and Jan 26, I suppose. So when we went this one, after all the discussions, they took us to ICU. One of the doctors showed that oximeter. And he said, from doctor's point of view, it was just came to the market. It's a tabletop. I can see the pulses. I can also see the oxygen quantity and all these things the doctor was telling us. And the doctor in the PG, those who are practicing, all of them are keeping one pulse oximeter in their coat. And the doctor took and then showed to us that one. Okay. We never know about the name at all. Okay, this is a doctor, something they are measuring that one, and it's a small battery operator, so I don't need big things. It will be fair enough to start with something like that, he was telling us. None of the engineers, we didn't bother about that one. We said, okay, very nice, very tabletop and tiny and other stuff we left this one. But when it comes to COVID, then you come to know about what is this one. This is one of the things. Same thing. Now if you see this one for diabetic, the people used to give a sensor, right? So that sensor, some 10 years before or 5 years before it started off making this one, right? So, you know, what doctors used to do, this one is a flexible wire, they just press it. And 15 days, every 15 minutes, this will give you a monitoring of our blood sugar level for this one. That will be taken by the doctor and suggest what needs to be done further. Now, the era is completely changing for this one, right? Earlier, if you take MRI or a CT scan, doctors used to go to the labs and operate for this one. Now, no doctors, no radiologists used to go to this one. They sit at home and then work with the different things. All their servers will be connected to their room. In their home itself, they see this one and give the report for this one. Even doctors in their mobile, they have their servers and they open this MRI and the CT scan and then do these things. This has happened pre-COVID. And post-COVID, things are becoming much more than that one in such a way that how things are trying to move this one. Robotic surgery is very much known to all of us for this one. But recent days, microsurgeries came to this one. There are many specialties used to come in the healthcare system for this one. This is trying to improvise the life of our people, make it very comfortable for us. And you know, earlier we used to, doctors used to stitch it. But now, if any ortho, they don't stitch it, they put a stabler, right? And inside the body, they have a diffused stitches, right now. You don't need to go and cut it. After a few days, it will automatically, cut and then it will be straight from the system. These are all the technology, but is there. It's not only that. Now, today, people used to make a pacemaker. And earlier, the life of the pacemaker is something like 5 years. After 5 years, you got to cut it, remove the battery, and you put the another battery. Then the life is improved to 10 years. Now, there are US is coming up with a new battery that you don't need to replace at all. It is like an energy harvester. The heart, which is going to push up and down, from that they generate energy using a piezo polymers. That will give a small capacitor, high capacitance, and that will be charging that one, and that will be used for this one. And if you look into sometimes when I visited that CC, they call cardiac critical care. ICU is for intensive critical care. They have CCU. So I can see this one. There are some people where kept the pacemaker in 2015. You can see here is a very big in size. The size is keep on thinning down like that. These are all, and now it can be monitored, and this will also given to the doctor that one how it is performing in a way later stage for this one. Okay. I was telling about doctors are the best statisticians for this one. How many of you are aware of that one when they do this stent, like typically angioplasty, when they put this one, 100% it is not going to work. For your information. If 10 people are putting a stent, only 5 people will work. Among the rest of the 5 people, 2 people within a week they will get a pain once again for this. For 3 people, it may take 1 more year for this one because it depends upon the body conditions for that. Right? The people we are trying to work on this one. After we are placing the stent, can I sensitize? Can I find out that what's happening? Inside our blood vessels, endothelial cells used to be there. And what used to happen that when you put an external material inside in that one, it will consider to be an external material, and some of the endothelial cells will try to grow very fast. So the cells will grow above that one and try to block the flow of blood for this one. So now what doctors find out that one, they will put they coat with already a drug coated stents were available for this one. We may not know. If you go to some cardiologist, they tell us this is a basic stent, it will be 25,000. Drug coated will be 50,000, and another one is a diffused what you call as the stent will be 1 lakh. You choose which one you want and we will put it. That's all they say this one. That's what it is here, the different things. Suppose what is happening in this one, if suppose endothelial cells are start of growing for your case, if you already put a drug, the drug will try to kill that. It won't allow to proliferate for this. But the thing is, what is happening, if suppose you put a stent and if you get a pain after a week, if this ECG or echo will give you only this one, there is an anomaly is happening, that's all it will happen. That one. Why is it happening, people do not know. So you have to put once again a catheter all along the way and see whether blockage had happened once again for this. That is a tedious process. Now people are trying to come up with this one. Without that, can we do? Means you put like MRI, non-contact, without inserting anything inside the body, can you get this information for this one? So they try to make a digital system which try to connect with the real systems and see that one simulating a human person and then do this one. This is what even today any knee replacement or a pelvis replacement, people come up with the 3D printers and based on X-ray, all the X-rays will be connected together and make how your pelvis looks like that one. And then 3D printer will do this one and it will be inserted. This will be a perfect fit, assuming that one. And monitoring will also happen. When they fit this one, what is happening to the system? This kind of a digital thing will be helping this one, apart from diabetic and other cases also. So this is the way how today's engineers and doctors are trying to work together to come up with teachers, doctors and engineers kind of interactions. I'll take another 10 to 15 minutes and we'll finish it off there. Okay. So, what are all the components which we will have in this digital thing? You can see here that one, of course, software and hardware is mandatory. Without that, nothing is going to happen to this one. Simulation and models are mandatory. And then, without input data, we may not be able to do that one. This input data, how do you get this one? The data will be coming from the sensors, which means that one. Electronics, communications, engineers is mandatory to look into that. Like business models for this one. So even management people are necessary along with the individual to take final decisions how to proceed in that. Right? So how do people decide the strategy like this? In India after 2030, diesel vehicles will be shut off. That would have been a decision people, marketing people would have been find out, or management people would have find out some 15 years before. That's why they would have started off making a hydrogen or hybrid engine or EV engine by that time. Once government announces, then you start making the unit. It will take another 3 years to come out from this. By that time, all foreign companies who have already developed the EV, they will come and sell in India for this one. They will take it out of the market. So for this also we need marketing and management people inside to understand that one, how the strategy is going to work for this. This is very important as an academician, I would say this one. And you see, in this kind of a digital thing, the idea or digital or virtual thing, whatever we talk about this one, you can see here from 2016 to 2022, the number of papers which was published. This was something like 2016 digital twin name was tabulated or fabricated, and 60 papers in 2016 in total across the world approximately. But 2022, you can see here it is going to be, it is some 13,500 papers published in that. So, which means that now by this time 2024, probably 2023, maybe 20,000 probably may be coming for this one. So, this is one of the new scenario which is coming from academic point of view, but at the same time, industries also. So, this is one of the topics which we might be, need to look into that one. And what is the advantages of this digital thing? This one obviously better R&D. Efficiency can be improved, which we also discuss about that. Product end of the life, reliability of any material, how much we can improvise that one. This will also come into the picture for this one. This is some of the examples of my last slide where the digital twin which is kind of used. For example, like large buildings and so on. So maintenance of the big buildings are very challenging for this one. Though this kind of a digital twin will be helpful for this one. Suppose we have G plus 20 floors. The top 20 floors, if something is happening, how do I identify that? And then complex projects like turbines, automobiles, and aircraft. As we discussed that one, that are all the things where also it is important. Power requirements are, green energy, what we call about that. How to reduce the power and improvise this one. Of course, manufacturing of the products. Sometimes when you see some of the industries, people used to put that even in Facebook or YouTube or in LinkedIn, any other digital forum, or you would have been seen this one. How many cars Toyota is producing, or within a second, how many cars Toyota is producing? There is a plan, right? I will take it out like earlier Kingston Motors was there, in Calcutta, like Ambassador. So in a day, what is the production limit? 100 cars are going to come out from this one, or 1,000 cars are going to come out from that one, right? Like that. And if you take this one today, Maruti or Tata Motors, they will say within a second, one car will be coming. Or within a second, we can get 7 cars will be rolling out from this one. Of course, there will be a lot of lines will be coming on that one. It's all automized and do this one. We need to also improvise the requirements. Suppose the requirement is 50,000 cars per month, and I make it only 30,000 cars in a month. Then the 20,000 people may not wait for one more month. They may go to alternative options for this one. So based on the need, I got to work. But at the same time, the need, I cannot also invest a lot. Sometimes it may shut down for this one. Then it will be all based. It will be ideal for some time. So this kind of a strategy is always mandatory. For that, the digital twin platform might be helpful for understanding this particular part of business. So since I am from mechanical engineering background, I try to take some of the applications towards mechanics oriented, mechanical science oriented. But as I told you that one, this is a truly interdisciplinary in today's world, and without the interdisciplinary, we cannot survive any proposals or any research profile for that. That's what at the end of the day, these are all some of the technology or technique which is available to enhance for us to take the decisions. With that, I stop. If you have any questions, I'll be glad to answer. Any questions? Yeah.
So, you told that optimization and machine learning are now synonyms. So, machine learning, is it a prediction model or is it an optimization?
No, it is a prediction model.
So, if it is a prediction model, then optimization model and prediction.
So, what is happening that one, suppose I have 5,000 data. Among the 5,000 data, there may be tons of parameters. But which parameter is crucially participating for that one, that I will be able to predict that. For example, like if you take an example for one particular a traffic in a road is pretty high, what are all the parameters which might be there? One thing is like the peak time is one parameter. Another one probably some kind of summer or winter maybe another parameters might be there. The third one, some kind of a meetings or some functions would have been there during that time. Sometimes what it could have been that there is a festival season where people will try to go. There are many parameters which will be involved in this particular time. This one. Among that one, which one you want to optimize? There are 10 parameters for this one. Do I need to make all the 10 parameters to be optimized? That is a multi-objective optimization. My process will be pretty high for this one. Rather, if I have 5,000 points, data points, among that one, 4,000 points are mainly related to, among the 10 parameters, only 3 parameters. So I will focus on first to identify the 3 parameters which I will be tweaking to get to satisfy my 4,000 parameters. Rest of the 1,000 parameters, I will look into the rest of the 7 parameters which might not be that important for us. That is the reason why first we do the machine learning to prediction, then it will be taken to the next level for the optimization. That's the way how it is.
Is it such that larger ones not just set in the prediction model, and
yes,
as a part of this, it is the optimization?
Yes. See, what parameters we wanted to control. For example, in another conditions what people used to do in particularly like diabetic cases, that one. They will try to find out when and all our body is getting peak. When we are getting a low sugar, when we are getting the high sugar part. Particularly this, for example, if you see this one, the bone density is different, the people, those who are in Punjab than in southern Tamil Nadu. Right, because one set of people use wheat, the other set of people use rice for this one. The capacity is completely different for this one. Right. So this is a data. Individual states are having a different data across India for this one. So we need to depends upon the localist one. So if I make a generic across India, if I want to make a system, it might be very challenging to get this output. So probably like make it a pocket and then do this one. For that we need a prediction. That predictions can be done by using an ML for this one.
Sir, is it so that after getting the result from the prediction model, whether that prediction how much is correct or accurate?
Yeah.
There I use the optimization.
Yeah, I mean, as I told you,
Is it the optimization or whether the data coming from the prediction output getting from the prediction model? Whether
Sir, may I add?
yeah.
In machine learning model, you will have for optimization, there are various optimization functions, just like gradient descent function you use. So optimization function is there. Your motto is to improve the performance through optimization. Okay, this is that is why sir talking about that is your optimization means machine learning. That is true 100%.
I think maybe I'm wrong, sir. For me, optimization technique is actually for how efficient the prediction model is.
This is also the same thing, no? So you when you have only 4 or 5 parameters to do the optimization, what is the importance of these parameters? There are 10 parameters can obviously make the system to get the best out of this person. What is the influence of it? There are some parameters will give 70%, some parameters influence maybe 30%, some parameters maybe only 5%. But if I am able to come up with the objective function for all the 10 parameters, then my optimization is the best optimization. But it is not possible for us to do that. That is the reason why this kind of tuning this data and then doing the prediction, then finding out is among the 10 parameters which are all the parameters, significant parameters that will help this one. That's why how. So this is statistics. As I told you, diabetics, if you take this one, you can take any kind of fruits. And the glycemic index for individual things, they will do this one. Even sometimes that one, if you have some allergic to this one, for some chronic allergy people, the doctors used to make 37 injections to the people. In a day, they make 37 injections. From here, they will keep on putting this, both the hands, 37. And then they find out the sensitivity of all, then they will get this one, which one is the crucial one, and then start treating this one. That is the one is the problem. No, I am able to take 37 injections for that one, that is the question for this one. So, that's what it is happening. So, how can I tune this one? So, in other words, that one, this particular season, if I am getting a flu, this may be due to this particular reason for this one. How do they get this one? The doctor will get 100 patients per day. And they start giving some basic medicines, that is fixed, that one. I will take, erythromycin, that is giving the comfortable this one. For this particular virus, erythromycin may not work, I have to go for something. These are all trial and error with the things. Here, this will help us to reduce that. That's it. Any questions? Generally, after 1 hour, it is very difficult to sit for all of us. Like we know that. That's why I don't talk more than 1 hour for any meetings. Any questions?
Sir, you talk about breeze vibration.
Yeah. Please go, sir.
So in this breeze vibration, so actually when the threshold is occur, actually this is due to Hooke's law, I think, sir.
Sir, there are two things. One thing is what I am talking about in vibrations means the resonance. The natural frequency of a particular system will have one. Due to the externally applied load, there will be a frequency will be exciting this one. So what generally we used to do this one, first 3 natural frequency should not match with the frequency which is developed due to the vibration. If it is there, this one will happen, that one, the system will start failing for this one. That is a vibrations point of view. What do you mean by resonance? That at that particular frequency, I need to identify what is the stress which is developed, what is the strength of the material for that one. If it is within the limit, it may be deforming, but it will come back to the original stage. More than that, it won't come back, it will permanently have a permanent deformation. After some time, it will, catastrophic failure will happen this one. Particularly concrete is kind of chalk piece and all brittle material. You never know what is the threshold. Suddenly it will collapse for this one. It can take more and more load. Some people used to say this one, I am very calm. This guy is calm. But one day after getting everything, he or she blast one day for this one. That is like the brittle. Some people immediately reacts for this one, right? So that's the way how the materials also operate for this one. So we need to identify that how it is working on this.
Thanks.
Sir, I have a question.
Yeah.
So what you just described about that we have to develop the stress, that whether it is developed based on the material, modulus or strain, whatever. So whenever we are designing the model in the software form, which software will be using for that?
So, for example, madam, from mechanical point of view, whatever I told you this example, that stadium one, they will measure the deflection by using the sensor. I stand here and jumping here. In the bottom of this floor, I keep a sensor. That sensor measures the deflection. That will go to the software. Input as a data acquisition system. That same displacement will be given in the virtual model in the software for this one. That virtual model will have the material of individual. It's a steel, it's a
I am
concrete.
asking from that software
I'll
which
come
is
to that
designing
one.
that part.
So that when it comes that one, for this particular load depends upon the boundary condition that will give you the stress. These are all will be calculated inside this one.
But whenever we will be designing in virtually, then we have to select the material, we have to choose the material.
That's already you know,
compositions.
madam. So for example, when I do the construction, I know that one is a concrete. So I will be putting the concrete material. I know
That
the steel.
parameter we will
All the parameters you will be doing in this particular case. For this particular load, at that particular time, you will see the stresses. This will be done with any commercial finite element software for this one. For us, if you take for us, we use Abacus for that.
So can it be done by COMSO?
Any kind of a software will do this one. COMSOL will do, Abacus will do, for mechanical, anything like.
The software which has a profession for selecting the smart materials and to get the parameters.
I extensively work in COMSOL because I work in smart materials, so I work on multi-physics problems.
So my research topic is also MEMS, that micro electromechanical system, where the SIMAT is designed using COMSO, where we have permission to choose the smart materials and the parameters.
Yeah. But for structures point of view, since you are asking about the stresses and other
3D
stuff.
design can be done also by COMSO.
Yeah, all the things you can do this one, but which is comfortable for us. There are some softwares will be put in some softwares are put in other stuff. For example, if I go for any civil structures, I will prefer to go for StatPro in one software for that.
And what the data we are getting from that software, that will be fed up for machine.
Yeah, the sensor has to be fed inside that particular one, and it is very simple example. There is one more example also is there in the for the same digital bin. What people used to make a cantilever beam. Like one end is fixed, another one is the beam, and at the bottom you put a displacement sensor. Manually by hand you apply the force for this one. What will happen? The sensor will sense the displacement. Via data acquisition, this will go to the your computer. In the computer, the same simple cantilever beam would have been manually using. I think it was done in Abacus problem. So this displacement, one end is fixed. This displacement would have given. You can really see this one when you are applying your force. Then you can see what is the stress which is developing. This is what it will. And after some time, what it is happening, that one it may give you information for you that one it is going to fail. Right one after some time, or it may go to larger deformation. Depends upon the material. That's what it is. So any kind of a software can be used. Only the interface is very important in this particular case. It should be on time, real time data acquisition should be there. For that, there are some what you call National Instruments kind of a few companies are having a good data acquisition system that can be used. I think it's a lunch time, right? For me also, because I got up morning 2 o'clock. My flight was 5 o'clock, so I couldn't sleep also. And also yesterday night I watched a movie in Prime Video. You know Prime Video, right? Netflix also. Yes. Time to time you should look into movies also. Okay, thank you. If no questions, thank you so much. It's an honor to be here.
Thank you very much, sir, for gracing us with your knowledge. It was indeed enlightening. Our I would request Dr. Sonupati Saha sir to come up and enlighten our guests with a moment.
Thank you so much.
Hey, Isha.